Okay, here are the notes on 3.4 Newton's third law. Okay, out of your note booklet that you have. Okay, so section 3.4. Okay, you should go through and make sure you can do most of these questions on your own, but I'll go through them here with you. Okay, so Newton's first two laws describe a different situation than Newton's third law. Explain and give some examples. So this is on page 159 of your textbook. Okay, and basically it's saying Newton's first two laws, they describe the motion of an object. So if you push an object, you're giving it force on that mass and it accelerates that at, depending on the force. Newton's third law, okay, is kind of an action reaction. So like by you giving that object force, your some of that energy comes from you, basically is what it's saying. So I'll write down how I'd answer this question. Okay, so yeah, Newton's first two laws describe the motion of an object in isolation. If you push a cart, it will move. That doesn't describe the force coming from you to push the actual cart. Okay, and explain the action-reaction forces. Give an example involving two different objects. So an action force is the force initiated by an object A on object B. The reaction force would be opposite of that. So the reaction force would be the opposite again, force exerted on object B on object A. So the example they kind of give in your textbook, okay, is the volleyball. So if the volleyball is object A, the volleyball and the action force would be the volleyball exerting force on your arms. Okay, and then your arms, object B in that case, would change the direction of the ball by exerting a force onto the ball to make it accelerate in a different direction. So for every action, we have a reaction. We have the two forces working together. The force initiated by object A on B, and then the force exerted by B on A. And then give Newton's third law as a statement and a force equation. And so I'll write that down and then read it out. So Newton's third law, if an object A exerts a force on object B, then B exerts a force on A that is equal in magnitude, so same number, but opposite direction. So the equation force of A on B would be equal to the negative force of B on A. Here you give an example of it. Action-reaction pair of objects in contact so an object's in contact and for objects some distance apart. So for objects in contact, lots of different examples. One you could use is like when a ball hits a bat, okay, when the volleyball hits your arms. Okay, there's many different. Anytime they actually come in contact, when you push a desk, okay, those would be action-reaction forces. Okay, example of objects that are some distance apart would be maybe magnets. Okay, they don't actually need to come in contact, but can still have the forces that either pull or push them apart. Okay, and then use Newton's third law to explain the motion of a propeller-driven airplane, okay, and of a jet airplane or rocket, and why are jet engines and rocket engines called reaction engines. So for a propeller-driven airplane, as the propeller rotates, it exerts an action force on the air, pushing the air backwards, which moves the plane forwards. So as your action would be moving the air backwards, and then the reaction moving the plane forwards. The jet engine or rocket, the action is the force exerted by the rocket on the exhaust gas. The exhaust gas is pushed back, okay, which would be the action force, and then the reaction, okay, is making the rocket or the jet airplane move forward. And so I'll put that in writing. Okay, so just writing down what I said there. So the force exerted on the ball for 4, okay, when it comes in contact with the bat is equal to the force on the bat on the ball. For magnets, okay, again, they don't have to be in contact to have that push or pull force on them. And then for question 5, just explain the jet or propeller-driven airplane and jet engine or rocket.